So today we're going to take a look at conditional probability. So conditional probability, let's take a look at this problem here. Given that a person sampled speaks English, what is the probability that they speak Chinese? So we know that they speak English. So in this bubble right here, so let's see, we got 35, 33, 13, and 8. So 5, 6, 7, 8, 16, 17, 19. So we have 89 people. And of those 89, how many speak Chinese? Well, here's our Chinese numbers right here. So 13 plus 8 is 21, excuse me. So we have 21 out of 89. So this is what's known as conditional probability. You're not taking it from the whole, you're given kind of a subset to choose from. And the trickiest thing probably on here is notation. P of A given, so this is this little line, the probability of A given B is the probability of A and B over the probability of B. So you guys did this right up here. If we were to look at this total here, let's see, there was 89 in this bubble, so 89, 93, 100. So there's a total of 105. So if we were looking at the probability of English and Chinese over the probability of English, that would be the probability of English would be 89 out of 105 speak English. The probability of English and Chinese is 22 out of 105. So our denominator's not 22. Why do I keep saying 22? That should be 21 out of 105. So we have 21 out of 89. We just kind of did it looking at that subset. Either way works. So let's take a look at here. What is the probability that you speak Spanish given you speak Chinese? So according to our definition, it's the probability of Spanish and Chinese over given that you speak Chinese, the probability that you speak Chinese. So 105 total, how many speak Chinese? 13, 21, 24, 26. So 26 out of the 105 speak Chinese. How many speak Spanish and Chinese? Well, that's just those right there. So 11 out of 105. So this equals 11 out of 26. I have a hunch you probably could have looked at this and just said, given they speak Chinese. So here's everybody that speaks Chinese. So 15, 16, 17, 18. So there's 26 that speak Chinese. Of that 26, 11 speak Spanish. So the last problem, we're going to just take a look at one problem today. Of a 53 staff at school, 36 drink tea, 8 drink coffee, and neither drink coffee or tea. So we got to figure out numbers here. How many drink coffee and tea? Well, we don't know that, so let's see if we can come up with a Venn diagram here. So we have tea, coffee, 10 drink neither. There's 53 total. We don't know how many are in the middle, so we'll put an X. Let's see, 36 drink tea, so we have 36 minus X. 18 drink coffee, so 18 minus X. So if we add these together, it has to be 53. So we have 36 minus X plus 18 minus X plus 10 equals 53. So 36, 54, 64 minus X equals 53. So X has to be 11. So if we go back here and write those in, X is 11. So this would be 25. 18 minus 11 is 7. I'll double check here. 25 plus 11, 36, 46, 53. So that adds up to that. So now we can take a look at our questions. how many staff drink both tea and coffee? Well, that's 11. Find the probability that they drink tea but not coffee. So in that tea circle but not in the coffee. So that would be 25 out of 53. If they drink tea, they also drink coffee. So this is kind of the probability that they drink coffee given they drink tea. So let's see here. So that'd be the 25. No, how many drink coffee? 11 drink coffee and tea out of our 36 total. 11 out of 36. Or we can look at the probability of both. So that's 11 out of 53 divided by the probability that they drink tea, 36 out of 53. So we get that same thing. If they drink tea, they do not drink coffee. So this is the probability of not coffee given that they drink tea. So out of those 36, there's 25 that don't drink coffee.